2, right?
So it's 8n minus 6n plus 2.
Yes. So now you can put the n's together, and what do you have?
2 plus 2.
What will your sentence be? What do you have left with when you do the work that you can do?
Well, it's 8n minus 6n.
Which gives you what?
2.
It does not give you 2. It gives you 2n. You see, that's going to be your problem. You keep thinking of these as numbers. They're not numbers. They're things. If you have 2 balls and I give you 3 balls, are you just going to have 5? No, you're going to have 5 balls. You have to keep that what they are with it, because what they are is going to make a difference. It's not going to be 5. 5 n's could be 5 million if n is a million. You see what I'm saying? We don't know what number n represents. It can end up being 2 billion. And if you have 5 of them, then you're going to have 10 billion, you see. You have to keep that variable represented because it's going to equal a value when we finally know what the whole thing has to equal. Right now, they're just saying, how would you find it? How could you simplify that expression so that when I tell you what n is, you can figure out what the whole thing equals? If you don't have n in there anymore, then all you're left with is 5. 5 plus 1, if n was a million, you're going to end up with $6 instead of $5,000,001. You see, that n is very important. You can't think of it as just something there. It is a value. And you have to think, if I have 5 of them and 6 of them, I'm going to have 11 of them. Whatever they end up being, I'm going to have 11. So if they end up being $100 bills, I'm going to have 11 $100 bills. If they end up being $5 bills, I'm going to have 11 $5 bills. You see, we don't know what it is, but we know that when we find out what it is, we're going to have 11 of them, or we're going to have 5 of them, or we're going to have 3 of them. You gotta not think of 5n plus a 5, because 5n plus 5 could equal anything depending on what n is. If n is 2, 5n plus 5 is 15. If n is a 3, 5n plus 5 would be 15 plus 5, or 20. You see, whatever n is going to make a difference of what that total. It's not just plus 5, it's whatever that is plus 5. So you got to figure out what that is. You're going to need to just go over those until it just gets in your head that that is just exactly what it says. You got to treat the letter as part of it because it is a quantity. Okay, and you'll find as we do these equations how important that is. Okay, we're going to skip that rectangle there because we don't want to start with the geometry yet. We're going to look at page 296. Now, as long as, see, sometimes it'll already be written out for you. It won't have parentheses and all that, but you have to learn that if it has parentheses, you can't start solving until you because you got to get it down to the unknown and numbers. They got to be separate. The unknowns plus or minus some number is going to give you something. But sometimes they don't just give it to you. Like here, they've put all the F's together and say we only have one F. The number is there. So you don't have to combine or anything. But if you have a sentence and it has parentheses in it, you got to know to get rid of those parentheses first by multiplying it by each number in there. If you have an exponent, if it said 5 squared, you couldn't leave it 5 squared. You'd have to say 5 times 5 is 25. You have to end up with a sentence that is, everything is just in its very simple form. You can't have it parentheses and like I said, exponents or square roots. You got to get it down to just a simple number. Once you got everything down to the simple number, then you can combine the letters together, combine the numbers together, then you can start solving equations. So you have to read this here in number 1, exercise 9. Always, as I said before, refer to that variable, just call it some number. This says some number plus 20 equals 57. What does that number have to be? 37. 37 is the only number that you can put where F is and get the answer that they say. So your answer is F equals 37. Simple as that. The next one going across says, what does 8y mean?
Multiplication.
That means 8 times some number is equal to 96. What is that number? 12. You see. You following that, Nicole? Okay. The next one says some number, take away 19, gives you 28. What will that number have to be? 47. You follow that? And what you did in all of those cases is what they're telling you on the pages before that that we didn't go over, that tells you to do the opposite. In your head, you automatically did the opposite to figure it out. In order to know what could you take 19 from and end up with 28, you actually added that 19 back into the 28. You see what I'm saying? In order to know what number times 8 gave us 96, you actually divided 8 into 96. So we're doing what it says, but we're not doing the work. Because when you can do it in your head, it just makes it that much faster. Sometimes you'll have to do the work because you won't just know the answer. So you have to understand that's what you're doing. You're doing the opposite. But we're just doing it in a shorter time, just by knowing what number has to fit there. Now the other thing is, anytime you're given a question like that and they tell you y has to equal, and they give you 5 choices of what y is, you could take each one of those choices and put it in. As long as you can read that expression, you understand that it says that 8y equals 96 means 8 times y equals 96. If they gave you choices down there and said that y is 5, y is 11, y is 12, y is 15, y is 20. You could just take each one of these and put it in where y is and see if it's true. Because it's only going to be true for one number. If y is 5, then I'm saying 8 times 5 is 96. And we know that's not true. You see what I mean? That's why the y's mean something. Because it is not just 8. It's 8 times whatever this is. That's a quantity. 8 of them is 96. So sometimes you'll have choices, and you can figure it out by that. Other times it'll be this simple that you can just read it and say what number has to fit there. Let's go on to number 2. What does this say to you? Some number divided by 3 is 9. You see? Some number, when you divide 3 into it, you're going to get 9 for your answer. And what is that number? 3. So 3, I knew you would say that. That's why I wanted to. Is 3 divided by 3 9? No. What number do you divide by 3 to get 9?
No, it is 3.
Then divide 3 by 3 and show me that the answer is 9. Put 3 into 3 and get 9.
Oh, no, it's not 3.
What number can you put 3 into and get 9 as the answer? If we're dividing, what's the opposite of dividing? When you multiply 3 times 9, what do you get?
27.
Then that has to be the number. You could have written it like this to yourself: what number can I divide 3 into and get 9 as the answer? That's what it says. That's what the question is. And that lets you know it's 9 times 3, because we talked about the fact that if you want to find this answer in here, it is always this times this equals that. That's how you got that as your answer. It's 27 that you can divide by 3 and get 9. So you have to, again, understand what the question is asking you too. You got to be able to take 3, put it into that, and get 9 for your answer. Okay? 33 says, the next one says 33 is equal to some number, take away 8. What would that number have to be? 41. If I took 8 away and ended up with 33, if I want to know what I had in the first place, I could just add the 8 back, right? That's the 41. Again, the opposite. 11 is equal to 2 times some number. What number is that? What times 2 would give you 11?
Times two.
Mhm.
Yeah,
5.5. 5.5. Okay. The next one says 15 times some number equals 75. What is that number? We're on page 296, Jeff.
Okay.
What is that number? Taking you guys too long. 5. 15 times 5 would give you 75. 42 is equal to what number plus 7? 35. 18 is equal to what number take away 6? 24. Okay. Do numbers 4, 5, and 6 all the way across. Now, Nicole, just so you don't feel so bad, we've gone over this several times in the past, and so some of them already have these answers in their book. It's not that they're